This video is about finding the sum of finite geometric series, which is also known as partial sum. And finite here means that you can count the number of terms. Like in this case, okay, we know that it's 1, 2, 3, 4 terms, okay? Alright, so the sum of partial sum or finite geometric series is given as S sub n equals a sub 1 minus r to the n over 1 minus r, okay? Now, remember that r equals a sub 2 divided by a sub 1 or a sub 3 divided by a sub 2, okay? Alright, so we know what is a sub 1, which is 5, and we can find r. R is 15 divided by 5, which is 3, or 45 divided by 15, which is 3. So we know r equals 3. Okay, we also know what is n. N is 1, 2, 3, 4. This is the number of terms. Okay, so let's find the sum of this series here. So f sub 4 equals a sub 1, which is 5, 1 minus r, and r is 3 raised to the n, which is 4, over 1 minus r, which is 3. So s sub 4 equals 5, 1 minus, now 3 to the 4, that is 81, all over negative 2. Okay, so s sub 4 would be 5 times negative 80 over negative 2. S sub 4, 5 times negative 80, that's negative 400, divided by negative 2, that is positive 200. Okay, and we could verify that with the calculator. Let's verify that. So it is 5 plus 15 plus 45 plus 135, and here we have our 200. So you might be wondering, why do we need to know this formula if we can use a calculator to do it? Not all the time we will have terms that we can actually count the number for it. Okay, so this is example 1. Let's look at example 2. So that is why we need to know about this formula here. So example 2 is asking us to evaluate the geometric series of, now we are using sigma notation, k equals 1, 4 to the k minus 1. Okay, remember that the formula is s sub n equals a sub 1 minus r to the n over 1 minus r. And remember from arithmetic sequence and series that remember that the number up here tells how many terms. So we know what is n. We know that n is 7. Remember that the number up here also tells what the last term is. Okay, but in this case we don't need that. Alright, this number tells what the first term is. We're going to put this number in this function to tell what the first term is. You put this number in this function to tell what the last term is. So we can find what is a sub 1. A sub 1 is equal to 4 to the 1 minus 1, because k equals 1, so we replace the k with 1. So a sub 1 equals 4 to the 0, and remember that anything raised to the 0 power is 1. So we know that a sub 1 equals 1 as well. Okay? So from this form we know what is a sub 1, we know what is n, now we need to know what is r. R is any number that your k is raised to. Okay? Any number that is raised to your k. Any number that is raised to your k, that is r. So we know that r equals 4. Okay? So we're going to use these three things now to tell what the sum is. So remember the sum, s sub n equals a sub 1 minus r to the n over 1 minus r. So s sub n is 7, s sub 7 equals a sub 1, which is 1 minus r, which is 4, raised to the n, which is 7, over 1 minus r, which is 4. Okay, so s sub 7 equals 1 minus, let's see what is 4 to the 7. So 4 raised to the 7 equals 16384 all over negative 3. So S sub 7 equals negative 16383 over negative 3. Now the negative divided by negative will be positive, so S sub 7 equals, let's find out what that is, 16383 divided by 3, and that is 5,461. That would be the sum of the seventh term. So this is similar to when you're looking at arithmetic series with sigma notation. Remember that you use this to plug in this function here to tell what your first term is. Remember that this number here gives two pieces of information. It tells what n is, and it also, when you put this number in this function, it tells what the last term is, but in this case we don't need the last term. Okay, let's look at our final example, and it says, example 3, it says find the nth term. So this time they want us to find n, and they say a sub 1, which is the first term, is negative 2, r equals 5, s sub n equals negative 62, and they want us to find what is n. Okay, so we're saying, remember that s sub n equals a sub 1 minus r to the n over 1 minus r. Okay, so where s sub n is, we're going to replace it with the value for s sub n, which is negative 62. So that is negative 62 equals a sub 1, we're going to replace it with negative 2. 1 minus r, we're going to replace r with 5, so that is 5 to the n, over 1 minus r, which is 5. Okay, so this is negative 62 equals negative 2, 1 minus 5 to the n, over negative 4. Okay, so negative divided by negative is positive, and we could say 2 into itself goes 1, 2 into 4 goes 2. So what we would have is negative 62 equals 1 minus 5 to the n over 2. And then we multiply both sides by 2 to get rid of this 2 in the denominator. So negative 124, let's check that, 62 times 2, that's 124, right? That's negative 124 equals 1 minus 5 to the n. Now we could go ahead and subtract 1 from both sides. So this is negative 125. Negative 125 equals negative 5 to the n. And I could divide both sides by negative 1 to get rid of the negative. So 125 equals 5 to the n. Now with this, I could use several things to find n. I could use the laws of exponents here, but I could also use logarithm. So let's use logarithm. So I'll take the log of both sides. So I say log of 125 equals, remember when you take the log, this exponent is going to come to the front, so that would be n log 5. Then I'm going to divide both sides by log 5. Okay, so let's take it up here. So let's do this thing now. That looks like 3, but let's try it out. Log 125 divide by log 5. Yes, and that is 3. So 3 equals n. Okay, there are several other questions we could go through, but for the benefit of time, I hope this one help you for the worksheet to come and all the other questions related to this kind of thing. Next video we will be looking at a geometric series for infinity, okay, when you don't know the number of terms. Alright, have a good day.